Welcome to EPZ Pathshala. I am Dr. Himanga Datta. I'm an assistant professor in the Department of Linguistics and Contemporary English, English and Foreign Languages, University, Hyderabad. Today we are going to learn the module Introduction to Phonological Processes and Optimality Theory from the paper Introduction to Phonetics and Phonology. Here is the outline of our lecture. The first, we are going to discuss about what do you mean by phonological processes. Then we are going to discuss on constraint-based approach in optimality theory and phonological processes in Indian languages. Then we are going to do assimilation and OT model, de-aspiration and OT model, spiritization and OT model, insertion and OT model, deletion and OT model, germination and OT model. Then we are going to have a summary of whatever we have done. As far as the objective of this course is concerned, we focus more, we try to familiarize you with the basic processes of phonological processes which are functional in the world languages, and how these phonological processes can be captured through the constraint-based approach in optimality theory. That is our main concern here in this module. So here there are certain key terms or the technical terms that you have to be familiar with, and these terms are like assimilation, deletion, insertion, germination, spiritization, aspiration, and there are certain constraints in optimality theory that you need to be familiar with. These are faithfulness constraints and markedness constraints. Okay, now what is phonological process? First of all, before introducing phonological process, the technical terms, you should be aware of why certain things happen in the sound system of a language. Sometimes certain sounds are dropped, sometimes certain sounds are inserted, certain sounds are doubled, certain sounds take on the features of the neighboring sounds. What are these principles? These are the processes I'm introducing in terms of layman's definition. So okay, let's begin. That each language is a unique phonological system that makes use of phonological processes that are specific to it. The types of processes, however, are finite. This explains the universality of the processes and the phonological systems they give rise to. So here you should understand that each language is different from the rest. That means we have a specific phonotactic system operating within a particular language. So one particular phonotactics will give rise to specific phenomena in the phonological processes. However, you should remember that these phonological processes are not infinite. There is a kind of systemic approach. There's a kind of systematic approach operating behind these phonological processes. However, each language has got different phonological processes, and you should remember that phonological processes of a language is not universal. Every language has got its own phonological process. Still, we can subsume the phonological processes in one umbrella term in different categories. So phonological processes can be divided into two types. One is whole segment process and modificationary type process. So now we'll see what is whole segment process and what is modification type of process. Whole segment type processes are those processes that affect the segmental structure of the word by deleting, inserting, changing the segments from one contrasting segments types to another. This operates at the level of phonemes and modify segments in various ways. So if the whole segment gets affected because of certain process, as for instance, if we talk about deletion, we are deleting the whole segment. If we are talking about insertion, we are inserting a new segment. So the whole segment gets affected, isn't it? So if these kinds of processes can give rise to phonemes in a phonemic system of a language, whereas on the other hand, like the modificatory type of process leads to the increase of allophones in the phonemic system of a language. As for instance, assimilation, the segment gets changed because of the influence of the neighboring segment. So assimilation in terms of laryngeal features, if we talk about assimilation, voicing assimilation, if we talk about the place assimilation, if we talk about the vowel harmony, they are nothing but the modificatory type of system. They don't change the whole segment in terms of its change and alternation, but they are trying to modify the segment in terms of place and manner. Okay, now like let's see why this phonological processes. Okay, these phonological processes occur across languages, but how can we capture the universal typology hidden behind these phonological processes? Okay, so we need a particular theoretical mechanism to capture these kinds of universality. That's why we need a kind of theory that is very the current one with current one to address this kind of phonological regularities, this kind of phonological processes. And this theory is very is that's why we have addressed the notion of optimality theory. That optimality theory is a current research work which is a kind of used as a kind of research framework in most of the research works in phonological literature. So that's why we are focusing on the constraint-based approach in OT model. So you should know, first of all, let me discuss about what is optimality theory. Optimality theory abbreviated from OT. I can say in the next slides we are going to discuss about not optimality theory. I'm going to use the short form OT. So optimality theory is a non-derivational approach in phonological theory which talks about the universal typology across world languages with the help of ranking and re-ranking of the constraints. So optimality theory talks about the generator, evaluator, and the constraints. So we can generate innumerable number of candidates. An evaluator will evaluate, and on the basis of the ranking of certain constraints, that there's a two kinds of, there's a kind of conflict between two constraints, and those constraints are always faithfulness constraints and markedness constraints. So the dominance between the two conflicts, two constraints can give us to the optimal candidate. Here you should remember in OT that there is no absolute winner. Even the winner, the optimal winner, will also violate the least number of constraints. Constraints are believed to be universal, but the ranking of the constraints adds diversity to the language. So you should remember that constraints are universal. These constraints are found across world languages, but what is the difference in terms of the constraint ranking? That a language X is different from language Y on the ground that by virtue of the fact that the constraints which are dominant in language X may not be dominant in language Y. So the different ranking and re-ranking of the constraints can add to the diversity of human languages. So the concept of OT, the optimality theory, was first proposed by Prince and Smolinski in 1993. So this is the kind of rough background of what is OT. So let's see the process of assimilation in OT model. So what is assimilation? I have already said that if one particular segment takes on the features of the neighboring segment, then it is called assimilation. So in technical terms, you can read here from the slides. Assimilation is the process of substituting a sound or making alternation to some properties of a sound under the effect of another sound which exists near to it. Assimilation is a customary phonological process by which one sound develops to be more like the neighbor sound. There lies a physical specific link between a phonological substitute and its context. In the process of assimilation, the substitute takes on a feature of the context, while in the assimilation, the substitute loses a feature of the context. So here, what is crucial here in assimilation, that adjacency is very crucial in terms of assimilation. So the neighboring segment and the context plays a very important role in the process of assimilation. When we see the examples, the things will be very clear to you. Okay, let's consider some examples of regressive devoicing assimilation in missing. So missing is a very new language for you. One of my student research scholars, we have done this survey for her research. She has done this assimilation process. Let's see. So 2017 she has submitted her thesis. So missing is a Tibeto-Burman language spoken in the northeastern part of India. So here you can see the missing yup and ting, yup and ka. You can see here the ba turns into pa because of the following voiceless sound. Can you see here? Like ad and pa, the turns into the because of the pa. So what is the kind of regularity you can see here? You can see here the plus voice feature turns into minus voice feature because of the following minus voice feature, right? So this is a kind of pattern. Devoice like is a kind of assimilation, minus voice assimilation you can see here. So let's see the tableau for it. Okay, this example of devoicing, assimilation, and missing demonstrates that the voice segments of the coda position gets assimilated and takes up the voice property of the minus voice from the following onset, as we have seen here, because the change occurs in the final position of a word, isn't it? So to discuss about these things in terms of OT, it's very crucial. Otherwise, we can just kind of explanation. We don't have any explanation. Why is it occurring? This is a kind of description. These things occurs in a missing. But how can we represent these things in terms of, in terms of its specific theoretical framework? That's why we need the constraint-based approach in OT. Okay, first you can see the constraints agree. What do you mean by agree constraint? Obstruent clusters agree in voicing. Right? If there's obstruent clusters, minus sonorant, so they have to agree. They have to be either voiced or devoiced. Then we have taken the second constraint known as coda condition. Coda cannot license place features. There is a kind of restriction. There are certain segments which can occur in the coda. Then we have taken the constraint style laryngeal. That means low laryngeal features. That faithfulness formulated as a correspondence constraint between input and output ensures that voicing of segment does not change. Then we have taken another faithfulness constraint called ident laryngeal, which means that consonants should not be faithful to underlying laryngeal specification. So what is the pattern of arranging these kinds of things, constraints? So here the dominant constraint will be agree. Agree dominates ID laryngeal, dominates star laryngeal. So here the arrow marks, if you see the slide, the arrow marks represents dominates. So agree dominates ID laryngeal, dominates star laryngeal. Okay, now you can see the tableau here. So we have taken one example from Dukpo, right? So here you can see the hand symbol, the C. Hand symbol means it's the optimal. That means it is the winner out of these constraints. So we have got three candidates here. So candidate A, Dukpo, candidate A, Dukbo, and candidate C, Dukpo. So candidate winner is C. So how we can make this winner? So it depends on the ranking of the constraints in the tableau. So we can see here the agree. The highest rank constraint should be placed on the leftmost column of the table, and the lowest rank constraint should be on the rightmost column. So here the star mark, that means it violates, and one is critical violation. So the candidate A violates agree constraint, which is critical violation. It also violates coda condition and star laryngeal. Candidate B violates coda condition, ID laryngeal, and star laryngeal. 3 is violating. Candidate C violates only ID laryngeal. You can see G is there in the input and K is there in the output. That's why there is only one violation. So because of this least violation, it is the winner. So we can see here that the agree dominates coda condition, ID laryngeal, and star laryngeal. So agree is the the absolute, the constraint, the highest constraint in missing. That's why we can get these kinds of candidates. So this is the way we can give explanation in OT framework. I have already said these things, so you can have an idea about what these things. Okay, now we are moving to another feature, phonological process known as de-aspiration. De-aspiration OT model. So before de-aspiration, you should know what is aspiration, right? So aspiration in common terms refers to the presence of extra puff of air in the release of consonantal segments. Aspiration is one of the characteristic features of Indic languages. So if I say pa and pha, this is a kind of aspiration. We are making the pa as aspirate. Pa, pha, ba, bha, ta, tha, da, dha. These are all aspirates. Aspiration is mostly prominent in the onset positions and word initial positions, whereas it gets lost in the coda positions. So this is a kind of universal feature that we have addressed in the world languages. The aspiration is most prominently seen in the onset position rather than in the coda position. Now see one example from Assamese Indic languages. Coda is de-aspirated when it is followed by an aspirated onset. So if the coda is also aspirated and if the following onset is also aspirated, there's a kind of the aspiration of the coda gets deleted. As for example, you can see here the example kot, khon, what happens, the output, if you say in fast tempo, kot con turns into kot con, rot con turns into rot con. You can see here the examples. Okay, the slide, you can have a look. Now OT constraints. Now why these things are happening? So we have certain constraints which are responsible for the emergence of such kind of winners. So we have seen the constraints as coda condition. The feature split glottis is not allowed in the coda position. Then star SZ, that means the feature split glottis is prohibited. Then we have taken the constraint max SZ, the feature split glottis is in the input, must have a correspondence feature as in the output. That means you should not delete the feature. The fourth candidate we have taken is star OCP SZ, that means obligatory contour principle, that no identical adjacent auto segments, no identical segments should be adjacent together, and means avoid two instances of adjacent spread glottis. Means if two candidates of aspirated consonants occur together, that you should that will violate OCP, so you should not be together. So let's see which constraint is the absolute the highest rank constraint in this table. Okay, let's see the tableau. Okay, so I am taking here the example cot con become cot con. So let's see what is happening. If you look at the tableau, what happens? That we have got three candidates here, right? A, B, and C. So cot con, the first candidate, you can see here, the coda is also th, the onset is also kh, right? So you can see here it violates the first candidate violates the top rank constraint that is called OCP. So it's two candidates of SZ cannot stay together. Then it violates coda condition. Then it violates the lowest rank constraint straight glottis. The second candidate, it has not violated the OCP, but it violates max SZ, right? Second candidate. And it violates the lower rank constraint star SZ. The third candidate, cot con, it violates second constant max SZ plus coda condition is violating the crucial violation here. So if we observe the violation of the candidates of the violation of the constraints by the three candidates, what it appears that which violate less constraints. So you can say out of B and C is a tie. If you see B and C, then B violates only max SZ and star SZ, but C violates, apart from max SZ and star SZ, it violates coda condition. So it loses, and the optimal winner is B. So this is the ranking of the constraints in Assamese coda de-aspiration. The star OCP will be the highest rank constraints. Okay, I already explained. So in this coda de-aspiration, ranking schemata can be represented in this following way. The star OCP SZ dominates, max SZ that dominates, coda condition and star SZ. This is the ranking of this constraint. Now let's move to another phonological process known as spiritization. Spiritization is a very the process of lineation. Spiritized process, you can say that the process in which the plosives turn into fricatives. So spiritization is a process which can be subsumed under the process of lineation or weakening process in phonology. So let's see some examples from Assamese aspirated stops. Pa and bh turns into f and v in word final position, leaving the unaspirated stops intact, which I have mentioned in my paper on spiritization 2012. Let's see. So here the word and spiritization. Can you see here the changes? Like p turns into f and bh turns into v. This is the labiodental sounds. Labiodental fricatives has become, although the things are is bilabial aspirated stops turns into labiodental fricatives. So there's a change. So let's see what are the things hidden behind this kind of phenomenon, how we can represent in terms of OT constraints. So in terms of Kitchener's model, we have to show this framework that spiritization. So there two constraints we are taking into consideration. One constraint known as lazy constraint, which is proposed by Kitchener's, and ident continuant. So identical continuant, that means if we see the p is the input if the output is per, then it violates the crucial constraint lazy, and if F is the winner, then it violates ident continuant constraint. So let's see, this is the kind of mechanism and responsible. So what is lazy constraint? The minimize articulatory effort. So Kitchener 1998 upholds this approach by virtue of the fact this parenthesis involves less articulatory effort, then stops under the definition of effort as a mental estimate of the neuromuscular activation levels required to achieve some set of gestures. From this perspective, an assumption has been drawn by Kitchener that an articulatory gesture of greater displacement is more effortful than one of lesser displacement, and ident continuant is corresponding segments in input and output have identical values for continuancy. Please remember, the constraints have, when we formulate the constraint, it must have some kind of empirical findings. We cannot create our own constraint the way we feel like, right? So first we have to see the data, the way they operate, then we can go for the constraints. Then we have to arrange, we have to be very careful in using the constraints and in terms of dominance so that it doesn't violate other constraints. We should be careful about the first thing we should take care of in this OT representation. We have to see the data. First, we have to see the phonotactics of the language. Then we have to arrange the constraints. The constraints are not only for a particular data set, but for the whole language. So you have, whenever you write OT representation of a particular language, so first and foremost thing you need to do, study the phonotactic patterns of the language, then try to see the faithfulness constraint and what are the constraints which we can, place it higher so that we can have some kind of marked effects in the particular language. Okay, now another process known as insertion in OT model. So insertion, you have to insert a particular segment from outside. Like insertion takes place when one or more segment is added to a morpheme or a word. Let's see, like in certain dialects and certain varieties of Hindi SC clusters, like word initially E is inserted. As for instance, the English word like school and then Sanskrit word smarak, stri, they will pronounce as iskul, ismarak, istri. So this is very productive phenomena. Even in loanword phonology, most of the people use these kinds of patterns. So here, to represent this kinds of E-insertion in phonological module, we have to invoke certain constraints, and these constraints are star complex onsets. That means onsets are simple. So always remember, in OT, everything is said in a kind of negative fashion. Like star complex onset means onsets are banned. Complex onsets are banned. That means onsets should be simple. Depth means don't insert any segment, and contiguity means avoid epenthesis, the middle segment. Let's see how it operates. If we see the candidates here, the input is school. The first candidate violates complex onset. Complex onsets means they should not be complex. Here you can see the SK is a complex cluster, isn't it? So it violates the first crucial the constraint. Second is B, is cool. It violates depth constraint. That means it has inserted one additional segment from the input that is called E. That's why it violates one. And Sikul. Sikul violates depth and contiguity. It has not only depth but also there's epenthesized one between Sa and Ka. That's why you can see here from this tableau, you can say that the B is a winner because it violates only one constraint. Iskul is a winner. So this is a kind of representation. So this is a star complex onset is the top rank constraint in these varieties of Hindi. Next, we are going to another process called deletion and OT model. Deletion takes place whereas insertion is inserting certain segment, deletion is deleting certain segment in a given context. So here we are taking one example, Varari, spoken in Vidarbha region of Maharashtra. One student, research scholar of mine, More Deepak, he has done this kind of research. So we are extracting the data from his research. Here the process coda deletion is employed as a repair strategy to repair the marked structures, syllables with coda to produce less marked, relatively well-formed structures. Here you can see here how the coda gets deleted. If you see the data in the slide, here you can see Sandaptat in Marathi, Varari becomes Sandapta. Mangtat become mangta. Here you can see the last consonant of the sound gets deleted, isn't it? It's very interesting. The see Marathi, the words are from Marathi, Varari. They are deleting the final segments. So how we can represent this phenomena in OT constraint? Okay, so to represent this kinds of phenomena in languages, we have taken into consideration two constraints. Max IO. Max IO means input segments must have outer correspondence, so we cannot change and we cannot insert. And no coda means syllables are open. Star C, that means syllables are open, so everything ends with a vowel. This is also one of the well-formulated constraints which requires the syllables must not end in a consonant or coda. Languages in which no coda is dominant have open syllables only. Varari doesn't have closed syllables, so that's why it ends with a vowel. So let's see how we can do this. So if the input is Sandaptat, A and B, two candidates we have proposed. So first candidate violates the no quota principle and second candidate violates max IO principle, but the winner is the first one because it violates no quota principle, because it ends with the first candidate ends with a consonant. That's why it violates no quota principle, which is very highly ranked constraint in Varari. So that's why we have got this kinds of phenomena. Okay, next is germination and OT. Germination refers to the doubling of consonant segments. Some segments undergo the process of germination frequently, whereas others don't. As for instance, geminate obstruents, they undergo germination more as compared to geminate sonorants. So this is cross-linguistically proved. So we can see here I am taking the data from some of my papers in Pali segmental asymmetries. This is language Pali. How the Pali behaves in terms of germination whenever roots are from Sanskrit. You can see here Atma turns into Atta, Shabda turns into Sadda, Shabda turns into Satta, Ukta, Utta, Shukla, Sukla, Sukka, Satpurusha, Shapurusha. So the close investigation on the Pali data shows that the segment in the onset position is not susceptible to alternation, whereas segment in the coda position is prone to change. The segment in the coda position assimilates the segment in the onset position. It further highlights the issue of whenever there are two adjacent obstruent clusters, one in the coda and another in the onset, the segment in the coda assimilates to the following consonant in the onset position, thus it establishes the dictum of positional privilege. As we have said, that onsets are stronger and codas are weaker. So this kind of phenomena in languages of Pali and all, they reflect the similar kind of dichotomy that exists between onset and coda. So here we have taken like the constraints. I didn't see followed by V. This is a positional faithfulness constraint which assigns supremacy of onsets over codas. Then we have taken the constraint the agree CC, that adjacent consonants need to be identical in implies star human C2. Then star geminate obstruent geminates are avoided. Let's see the W. Okay, I have taken one example, Ukta. So Ukta, it violates agree CC because it has got Ukta, because it should be Ukka. The two consonants are different. That's why it violates the first constraint. Second constraint, candidate, it has not violated the dominant rank constraint. See, Utta, it's a kind of geminates. Agree CC is there. But geminate obstruent, and that you should not geminate obstruent, it violates the lower rank constraint. Ukka violates ident CC because here the KK should not be there because onsets have to be given preference over coda. So this is the thing. That's why Utta, the candidate B, is a winner because it satisfies the top rank constraint agree CC and ident CV, that is a kind of onset, so that talks about the onset supremacy and positional faithfulness. That's why although there's a tie between Utta and Ukka, the B is a winner because it does not violate ident CV. So this is the way we can have kind of representation in OT framework. So what we have learned so far, that we have discussed the major phonological processes such as aspiration, assimilation, spiritization, insertion, deletion, germination, with reference to the data of Indian languages collected from published descriptions. I have intentionally kept the Indian languages so that you might be motivated to do research in future on Indian languages and phonology. This is very fascinating and interesting. India is a hub of languages, and if you do research in future in phonology, you will find it very interesting. There are so many aspects of phonological processes that you can handle in future. And the focus of this module was not only on phonological process, but the constraint rankings and re-rankings and optimality theory. Obviously, the focus, you have already have a module on phonological processes. Here the focus is on how you can apply this, the processes of phonological processes, and how we can see as how this the phonological processes operate in the language, within the metrics, within the functional categories of optimality theory. That is very important, as how we can establish the universal typology across languages in terms of phonological regularities. That is the main concern of our focus. And we have seen here how the rankings and how the constraints behave. There's an interaction between faithfulness and markedness constraints, and it has always gives rise to the fact as how underlying phonological patterns works in languages in a systematic fashion. That you should remember, and at the end, that phonological processes are finite in number, although they vary from language to language depending on the phonotactics and ranking schemata of the constraints in respective language. OT constraints, which are responsible in phonological processes, talk about the universal typology that are evident across language, across human languages. Okay, that's all for this module. Hope you have enjoyed this module and learned something about this module, phonological processes in optimality theory. And if you want to read more, if you want to know more about this kind of phonological process in OT, please refer to the e-text of UGC ePathsal. Thank you.